16, 17, and 18, we're now using the odd and even properties. So if I go to my trigonometric identities, whoops, slide, there we go. They have the cofunction ones that we haven't talked about yet here, but we have the odd and even function identities. So the sine of negative theta, the negative goes in front of the sine of theta. Same thing with the cosecant. Those two things are inverse of each other. When you have the cosine of negative theta, it turns it positive. Again, with the secant, those ones are inverse of each other. With tangent and cotangent, the negative's in front. So sine, cosecant, tangent, and cotangent, the negative goes in front. But if you have cosine or secant, it's going to turn positive instead of negative. So those are your odd and even cofunction identities. And that's usually my first step when I'm working with these, is to look to see, do I have any of those I can rewrite? So again, I'm going to go back over here. I've got the sine of negative x minus the cosine of negative x. Well, the sine of negative x, I'm going to put negative sine of x, 1 minus, and the cosine of negative x is just the cosine of x. And that's using the odd and even identities there. So now, once I have it written like that, then I want to worry about simplifying. We had one like this before where we had 1 minus cosine of x in the bottom, and we said we wanted to use the conjugate, 1 plus the cosine of x, to simplify. So I'm going to take negative sine of x over 1 minus the cosine of x times 1 plus the cosine of x on both the top and the bottom. And that's just going to use algebra there when we do that. So again, on this one, I'm just going to leave the top how it is. Negative sine of x times 1 plus the cosine of x. On the bottom, when I FOIL that out, I get 1. I'm going to get plus cosine of x and minus cosine of x, which cancels out, minus the cosine squared of x. Again, that's just plain old algebra multiplying that out. Again, notice here when we did that, we ended up with one of our Pythagorean identities. 1 minus the cosine squared of x is equal to the sine squared of x. So negative sine of x times 1 plus the cosine of x over sine squared of x. That's one of our Pythagorean identities. Here, I can cancel out one of the sines of x. So cancel that. Here I'd have this. I will have, using my distributive property, negative 1 minus the cosine of x over sine of x then. That's just doing algebra. I just cancel that out and I multiply that out. Now I don't know how picky Alex is. You may have to do that in 2 steps of algebra. One where you cancel and then one where you use your distributive property. Sometimes it's pickier than others, so you might have to do 2 steps, both doing algebra. Hopefully 1 step just works. Then I'm just going to separate this into my 2 separate fractions. So I'm going to have negative 1 over the sine of x, and I'm going to have minus the cosine of x over the sine of x. Again, trying to smush this all in here. That step there is just doing algebra. 1 over the sine of x is my reciprocal identity for cosecant of x. So I'm going to have minus the cosecant, I'm trying to write cosine, minus the cosecant of x. And then this is going to stay the same because unless they're both the same property, it's only going to let you do one at a time. Again, this property here was my reciprocal property. Then here, I can use my quotient. If I have the cosine over the sine, that's equal to the cotangent. So I'm going to have minus the cosecant of x minus cotangent of x. That's my quotient identity. And now I have my proof finished. So again, I could have probably used more writing room, but I'm writing kind of big so you can read. So odd and even function first. We did algebra again. We used the Pythagorean identity. We canceled and used the distributive property. So we did algebra, divided up into two separate fractions, which again was algebra. We did 1 over the sine of x is cosecant of x, my reciprocal identity. And then we did cosine over sine is cotangent, my quotient identity. Number 17 then. Again, we're going to use the odd and even functions. The only two that become positive are cosine and secant. The other ones will have the negatives out in front. So I'm going to have negative cosecant of x over, this is going to be positive secant of x, plus this is going to be positive cosine of x over negative sine of x. That is my odd and even functions. I've got two separate fractions. I want them to be one problem, so I'm going to go ahead and do my common denominator. So I'm going to put the negative in front. Negative secant of x, sine of x is going to be my common denominator there. And so here, negative times a negative is going to give me a positive cosecant of x, sine of x, plus this times this gives me secant of x, cosine of x. And again, just doing algebra there, getting my common denominator. Now, cosecant of x is the reciprocal of sine. Secant is a reciprocal of cosine. So I'm going to replace all of those using the reciprocal. Since I'm using the same identity, I can do it all in one step and I don't have to do them every single step one at a time. So I'm going to have here cosecant of x is 1 over sine of x times sine of x. Secant is 1 over cosine of x times cosine of x. On the bottom, minus secant of x again is 1 over cosine of x times the sine of x. And all of those are reciprocal identities, right? So here, this is going to cancel, this is going to cancel, and I am going to get 1 plus 1 on top, which is 2. Here, if I combine that into one expression, I have minus the sine of x over the cosine of x. Plain old algebra there. I'm dividing fractions, so I'm going to invert and multiply. I'm going to make that negative 2 times the cosine of x over the sine of x. Again, that's just plain old algebra. Cosine over sine is cotangent. That's one of my quotient identities. So negative 2 cotangent of x is my quotient identity. And now I have my identity proven. Starting with this, I ended up with that. You have more writing space, but I can't show a whole page at once, so I have to kind of smush things in there. And number 18, again, using that odd and even. So, secant, sine, and tangent, the negatives are all going to stay in front. So, this is going to be minus, nope, that isn't it. Secant turns positive. I'll make sure. Secant should stay positive. Misspoke there. So on this one, I'm going to have the secant of x, and then I'm going to have minus, and this is going to be negative sine of x times negative tangent of x. Odd and even. So, I'm going to get secant of x Negative times a negative is going to be a positive, so minus sine of x tangent of x. That's just plain old algebra. Now looking at that, secant of x is 1 over cosine. So I'm going to go ahead and do my reciprocal. 1 over cosine of x minus sine of x tangent of x. So that's going to be one of my reciprocal identities. Tangent of x is sine over cosine, so I can get a common denominator there. So I'm going to have 1 over cosine of x minus sine of x times sine of x over cosine of x. That's one of my quotient identities. So just doing some algebra here and combining that into one expression, I'm going to get 1 minus sine squared of x over cosine of x. Just plain old algebra. All right, so we have 1 minus sine squared of x over cosine of x. Right here you'll notice this is one of your Pythagorean identities. The sine squared of x plus cosine squared of x equals 1. So 1 minus the sine squared of x is equal to the cosine squared of x over the cosine of x. That's your Pythagorean identity. And then your last step on this problem, just canceling. So if I cancel out one of my cosines of x, I just get the cosine of x. And that's just plain old algebra. And now we have our identity proven. Started with that, ended with cosine of x. Should be good.